equations review for calculus. So remember, when we're talking about linear equation, we're talking about lines, and so we have three standard equations that we use. So we have y equals mx plus b, slope intercept, where it crosses the y-axis. That'd be our y, and our slope is our m. That's a big deal throughout the whole thing. Then we have point slope form. So if we're given a point and a slope, we can write this equation where the y and the x just stay in there. Slope times x minus x1. So the x1 and y1, that's our point, right? So this point slope form, because you're given some type of point with an x value and a y value. Remember, it's minus whatever those y values are, minus the x value. So every point in the slope, right? M is our slope. And then our final equation is standard form, so that's ax plus by equals c, where a is always positive and no fractions. No fractions. So that is standard form. So those are our three equations for linear equations. So if you're asked to graph this, right, all we need for a line is just 2 points. So the best way to do these ones is just plug in 0 and then solve. So divide by 2, y equals 3. So now I have a point, right? This is my x. I let x equal 0. So now I have a point, 0, 3. So I just graph that. And then the next time I'm going to come through, I'm going to plug in 0 for y. And then I'm going to solve. So divide by 3. Divide that by 3 is 2. So I get 2 for my x this time and 0 for my y. So then I can just plot those points. 0, 3, 2, 0, and then I can draw my line, right? I mean, I can put this in slope intercept form, so basically just solve for y. So if I subtract 3x, 2y equals minus 3x plus 6, and then divide by 2, and then it looks like point slope form, right? And so we have a graph in point slope form is we graph our intercept first. So we go up 3, 1, 2, 3, and then I use my slope, rise over run, so down 3 over 2. You can see that was the same one. So you can graph either way from standard form. Okay, putting into standard form, so that's when we want to get our x's and y's on one side with no fractions and no negatives for our x. So we can get rid of this fraction just by multiplying both sides by 3. So we get 3y equals 2x plus 21. So I got to distribute the 3 to both of them. And then we can go ahead. Don't want to move over my x because then it would be negative. So might as well just subtract the 21. So minus 21 plus 3y equals 2x. And then I can just subtract 3y. So it's okay that the y's are negative. So negative 21 equals 2x. My x's have to be positive and no fractions, so we're good. So there, it's in standard form. Okay, right in standard form, given a point and a slope. So first there's two kind of ways you can do it. You can go point slope form. So y minus my y value, which is 1, equals my slope times x minus x1, which is 3, so minus 3. So that's in point slope form. Now I can go ahead and do a few different things. I want to put it in standard form, so I don't want any fractions. So I could multiply both sides by 2, but then I have to distribute that 2 and get 2y minus 2. When I distribute this 2, all I have to do is distribute it here, because it's kind of like 2a times 3. I don't take 3 and times it by 2 and a, because there's multiplication here. I only have to take that 3 and just multiply by 2, right? So I only have to multiply by 2. Same thing here. I only have to take that 2 and multiply by the half. And so those are going to cancel. So I just get x minus 3. Or you could just distribute half to both of those. And then later on, you can take care of the fraction. Well, anyways, we're going to go ahead and add 3 to both sides and subtract 2y on both sides. So we have 1 equals x minus 2y. So there you go, no fractions in positive x. Okay, so there's it in standard form. Another way to do it is you can just plug in, so y equals mx plus b. You could just come here, so I can take in the 1/2. But I don't know my b, but I am given an x and y, an x here, or an x, or y here, and an x here. So I can plug in that 3 right here for this x. I can plug in that y for this y. And then I can just solve for b. Usually I only go this way if they're actually asking for this form. But so this would be 3/2. And then I would minus 3/2 from both sides. So 1 minus 3/2 is our b. So that's 2, so that's -1/2. So b is -1/2, so y equals 1/2 x minus 1/2. And then I can times everything by 2. And then I can go ahead and move that over, and you can see I'm going to get the same answer, right? My y's are going to move over, and my constant's going to move over. So remember, slope is m, it's rise over run. And when you're talking about physics, some of you guys are in physics, so you're going to see a lot of the same stuff, but it's your change in x, or sorry, change in y over the change in x. Right, it's called your rate of change. Or if we have 2 points, if we're given 2 points, you know, we can find that by taking y2 minus y1 over, and then x2. As long as you start with the same y's and start with the same x's, you're fine. Right, so that's how you find your slope if you're just given 2 points. Remember, parallel lines, you guys will always say never cross. Never cross. Mostly what I'm looking for here, parallel lines. Yes, they never cross, but the slopes are the same. So if you have 2 equations and they're parallel, their lines are parallel, the slopes are the same. That's kind of the big thing. And then perpendicular, they are going to cross at 90 degrees. That's what you're going to say, 90-degree angle, which means that they do cross, of course, but their lines are, their slopes are, and that's the important thing, slopes are opposite, means I change the sign. And reciprocals, which means I flip the fraction, reciprocals, I don't know if that's right. I mean, I don't know if the spelling's right, but perpendicular lines are opposite reciprocals. All right, so look at that, perfect, already done, and it's barely past 8 minutes.